Okay, class, so today we are going to introduce how we, as chemists, measure and compare atoms. So in chemistry, we need to be able to convert from units of one measurement for a chemical compound to different units of measurements for that same compound. Over the next few videos, we're going to talk about the different ways in which we can measure chemical compounds. If I could break this video down into one objective, it would be that you could calculate the average atomic mass of a compound. And saying that, let's jump into this. So in order to measure an atom or compound, we need to be able to numerically represent that measurement. So we are going to start off with first measuring the mass of an atom or compound using the atomic mass. As we have learned in prior units, the average atomic mass for a single element can be found on the periodic square. It usually is represented by a decimal number at the bottom of each square. For example, the element carbon has an average atomic mass of 12.001 atomic mass units. This makes it easy to determine the atomic mass of a single element. But what about if we have a compound like carbon dioxide? How do we figure it out then? Well, then we go on to making the formula mass. So now we are going from atomic mass to formula mass. We're going from one atom to a chemical formula. This is just the atomic mass of all the elements within a compound that are added together. So when doing these, I usually use a table to set up my formula mass. I will set up my table with these vertical columns. The first one being the element, next being the quantity of that element, and then being the average atomic mass of that element, and then my final one being the total of that element. When determining my total, I'm going to multiply my average atomic mass by my quantity of each element. So my carbon dioxide would look like this. Carbon is my first element. I have one of those, so my average atomic mass for carbon is 12.01. That means I'm going to take my quantity of my carbon, 1, times my 12.01, my atomic mass of carbon, and that's going to give me a total of 12.01 atomic mass units. Next, I'm going to use my oxygen. I have 2 oxygen atoms. The average atomic mass for each oxygen atom is 16 atomic mass units. So this would give me a total, if I multiply my quantity 2 times my 16, a total of 32 atomic mass units for oxygen. My last step in finding the formula mass is adding our totals together and rounding to the closest whole number. So 12.01 plus 32 is going to give me 44.01 or 44 atomic mass units. And that is how we find our formula mass for compounds. Let's do one more. Find the formula mass for a simple sugar called glucose. The chemical formula for glucose is C6H12O6. We start out by writing our table and filling it out. Then we can start with our elements. So our first element is carbon. We have 6 carbon atoms, so that's going to go under the quantity, and each one of those carbon atoms has an atomic mass of 12.01. So if I multiply 6 times 12.01, that's going to give me 72.06 as my total atomic mass for the carbon atoms. Next, we're going to go to the hydrogen atoms. With our hydrogen atoms, we have 12 of them. So that's going to go on our quantity of hydrogen atoms. Each hydrogen atom has an atomic mass of 1. So 12 times 1, that gives us a total of 12 atomic mass units of hydrogen. Our next part of the table is we have oxygen, and we have 6 of them. Each oxygen has 16 atomic mass units. So 6 times 16, that's going to give us a total atomic mass of 96 atomic mass units. Our last step is to find our total formula mass by adding our totals together. So 72, 12, and 96. That's going to give us 170 atomic mass units. Now that we have that under our belt, let's talk about moles. A mole is thought of as a chemist's dozen. When I say a dozen, it is highly likely that you think of the number 12. In chemistry, a single mole of an element or a compound is equal to the formula mass of one of those elements or compounds. So, for example, the element carbon has atomic mass of 12.01 grams, and that specific amount of grams is the same amount as 1 mole of carbon. So 1 mole of carbon equals 12.01 grams of carbon. If we take our formula mass of carbon dioxide that we found out earlier, the same concept is going to be applied. We calculated that the formula mass for carbon dioxide is 44 grams. That means 44 grams of CO2 is in 1 mole of CO2. In other words, 1 mole of carbon dioxide equals 44 grams of carbon dioxide. When using moles and the formula mass, we are going to have two types of problems we will encounter. One that gives us the amount of moles of a substance present, then asks us to determine the mass, while the other gives us the certain mass of a substance and wants us to find the number of moles of that substance. Both of these problems are going to have us using the formula mass and mole relationship to determine the answer. I'm going to make this easy on you though. If you are going for a mass and you're asked to figure out how many moles of a substance there are, you are going to use 1 mole over the atomic mass or formula mass. If I'm given the number of moles of a substance and I'm trying to figure out the mass, I'm going to use the atomic mass or formula mass over 1 mole. Now let's see how we use these relationships. I have a 40 gram sample of methane, which is CH3, and I want to know how many moles are in it. My first step is to put what I know over 1, so 40 grams of methane over 1. Then my next step is to bring out the trick that I showed you earlier. Since we are going from mass to moles, we are going to use the relationship 1 mole of methane over the formula mass. This is when we run into a problem because we are not given the formula mass of methane and we had to solve for that. So we go back and make our formula mass table. We start with carbon. We only have 1 of those. We write down that 1. It has atomic mass of 12, so we multiply 1 by 12 and we get 12 atomic mass units. Then we go to our hydrogen. We got 3 of them. Each one has atomic mass of 1. So that gives us a total of 3 atomic mass units. Now we can add our carbon and hydrogen together to get 15 atomic mass units, or 15 grams per 1 mole. Now that we have our formula mass, we can go back to our original equation and fill out our missing formula mass. The equation should read now 40 grams of methane over 1 times 1 mole of methane over 15 grams of methane. Our last step is to multiply our tops and bottoms and then divide them out. So we multiply our top and we get 40 times 1 is 40. Then we multiply our bottoms. 1 times 15 is 15. This gives us a new relationship of 40 over 15. Once we divide that out, so 40 divided by 15, we get roughly 2.67 moles of methane. And that is going to be our answer. So 40 grams of methane equals roughly about 2.67 moles of methane. Now let's work one going the other way. If I have 5 moles of carbon tetrafluoride, then how many grams of it would I have? Okay, our first step is to put what we know over 1. So we have 5 grams of CF4 over 1. The next step is to multiply by one of the relationships I stated earlier. Since I am in moles and I'm going to grams, I would use the relationship of the formula mass for CF4 over 1 mole of CF4. Once again, we do not know the formula mass off the top of our heads, so we're going to have to solve for that. We have 1 carbon atom at 12, so that gives us a total of 12 atomic mass units for carbon. And then we got 4 fluorine atoms, each of which is at 19 atomic mass units, so I multiply 4 times 19, and then I get 76 atomic mass units for my fluorine. Now I just add the carbon and fluorine atoms together to get 88 atomic mass units for carbon tetrafluoride. This is a number we can use back in our equation. So if we fill out our equation, it should say 5 moles of CF4 over 1 times 88 grams of CF4 over 1 mole of CF4. Now we just multiply and divide. Our top is 5 times 88, we get 440. Our bottom is 1 times 1, so we get 1. So our relationship is 440 over 1, or we can just say that is 440 grams of CF4. Okay, that should be enough for you now. Keep up the good work, and remember, take these problems one step at a time. Write down what you know, and then solve for what you don't know. Thanks for sticking around, and we'll see you next time.